This video is by request. Complex numbers in the frame of reference of trigonometry. Now, a complex number z is equal to some a plus bi. Typically, they're just a and bi are real numbers, okay? So I can call it z is equal to some x plus iy. This way, you will realize that the first component is associated to the x-axis and the y component is associated to the y-axis. Notice some arbitrary complex number z here falls to some x here on the real axis and some y here on the imaginary axis. I am for imaginary, re for real. Notice that I can create a line r that touches z and it is at some angle theta elevated off of the x-axis. Notice that now we can apply trigonometry. That triangle, take it out here, with the application of trigonometry, says that we may assert these values for the triangle. The y is the y, x is the x, r is the r. By the Pythagorean theorem, we get r squared is equal to x squared plus y squared, which implies r is equal to the square root of x squared plus y squared. Here's our first transformation equation from rectangular coordinates, which takes this complex number and takes xy as its ordered pair. We transform it into polar coordinates. We want to transform this into polar coordinates, where instead of x and y, we have r and theta. All right? We have discovered how to find r. It's in that box. How do you find theta? Well, to find theta, you have to use x and y. How do I find x and y? We just look at the triangle. What's the cosine of theta? Adjacent over hypotenuse, multiply both sides by r. This implies that x is equal to r cosine of theta. That's my transformation equation in x. This allows me to go from the rectangular value x to the polar r cosine of theta. And then sine of theta is equal to opposite over hypotenuse, multiply both sides by r. This implies that y is equal to r sine of theta. And here you go. You have the three transformation equations in the boxes. So, let us have an example here. Let us delete this stuff here. I'll delete just this part. Let z equal, I don't know, 1 plus I. Okay? In rectangular, 1 plus I becomes 1 comma 1. Okay? Then we graph such a 1 comma 1. And we'll replace this x with a 1, this y with a 1. I don't know r and I don't know theta. Okay? But now I can change this to this triangle. 1, 1. I can solve for r because I know what this equation becomes. R becomes square root of 1 squared plus 1 squared, which that's 1 plus 1, which becomes square root of 2. I already know that r here is now root 2. Now all that remains is to find theta. To find theta, we change x, which we know is a 1, and r, which we know is a root 2 here, and we change y, which we know is also a 1, and r, which is a root 2, like so. Then we say, what is the ratio of y over x? Y over x is really